Good day, everyone. So today we shall be diving into area of plane figures. We shall be exploring the fundamental concept of calculating the space occupied by two-dimensional shapes known as plane figures. Okay, so what is a plane figure? Number one, a plane figure, like I said earlier, is two-dimensional figure, meaning that it has length and breadth that lie entirely on flat surface. When an object lies on a flat surface, you can only see two sides, the length and the breadth. It composed of either straight line or curved line. An example of plane figure are triangles, square, circles, rectangles, and parallelograms. So these are some of the examples of plane figures. Right, so we shall be diving into defining and calculating the area of this plane figure. So what is the area of a plane figure? The area of a plane figure is just simply the measure of the space it occupies. So when you say the area of a plane figure, simply the measurement of the space the plane figure occupies. And understanding this area allows us to compare the space taken by different shapes and even create equivalent figures. Right, so having known that, we now look at the formulas for calculating the areas of different plane figures. For example, triangle. The formula for area of a triangle is half times the base of the triangle times the height. Okay, where the B represents the base, H represents the height, the vertical height actually. And for rectangle, the area of the rectangle is the length of the rectangle multiplied by the breadth, where the L there represents the length and the B represents the breadth. For a square shape, the area is A square, where the A represents the length of one side of the square. A square has all the sides to be equal. So the A represents the one side of the square, and then A square is actually the area of the shape. And for parallelogram, it's simply base times vertical height, where the base still remains the base and the H is the vertical height. And for circle, the area of a circle is pi r square, where the r represents the radius of the circle and the pi there represents a constant whose value is 22/7. All right. Now let's look at the geometric theorems for areas. There are theorems that have been formulated by some mathematicians concerning the areas of some shapes. So these theorems are crucial for constructing figures of equal areas in geometry. So when you are interested in constructing plane figures of equal areas, then you will need this theorem. And what are these theorems? The first one says triangles on same base. Okay, that triangles on the same base and between the same parallels have equal areas. Okay, so when you have two or more triangles, but they have the same base, they're on the same base rather, then it is proven, that been proven that these triangles have equal area. What do we mean by that? That triangles on the same base and between the same parallels have equal area. Now look at it here. Now this is yellow triangle, this is blue triangle, this is ash triangle, right? Now you can see that these three triangles align on this base here. Okay, they line on this base here. That means they are on the same, they are all lined on the same base. Since they are all lined on the same base, it has been proven that the area of the three triangles are the same. Not just that they are lying on the same base, but they are also lying on the same parallel. These two lines, they are parallel, and the line up and the line down are parallel lines. Remember, parallel lines are lines that can never meet. Now, these three triangles align on the same parallel line and on the same base. For the fact that they are lying on the same base and within the same parallel line, then their areas are the same. And what that means is that if yellow triangle has the area of, let's say, 15 centimeters squared, then this ash also will have the same 15 and the blue will have the same 15. Now the first theorem, geometric theorem concerning area of triangle. The second one says that the triangle on equal bases. Now, triangles on equal bases between the same parallel line have equal areas. The first one is the triangles on the same base, they are lying on the same base. But the second one is triangles of equal base. This second theorem, the three triangles are not lying on the same base, but their base are equal. Like this yellow triangle, let's say it has a base of approximately 2 centimeters. Then this second triangle too is having a base here of 2 centimeters. And the third one too is having a base of 2 centimeters. But the fact that they are having the same base, equal base values, and they are still lying within the same parallel line, then their areas are meant to be the same. Very key theorem in geometry. So these three triangles here now, they have the same areas. Their areas are the same because of two conditions. They have equal base and they are lying in the same parallel. Now the third theorem, geometric theorem, is parallelogram on same base. This theorem says that parallelogram on the same base and between the same parallels have equal areas. Okay? Now look at that two parallelograms here, the yellow parallelogram and the white parallelogram. The white parallelogram and the yellow parallelogram are lying on the same base here. This is the same base, okay? So they have one base. They are lying on one base here. But the fact that they are lying on one base and they are within the same parallel lines, then they have equal areas. So these are the three geometry theorem that we need to look at. But then there are more that are also paramount for us to know, and this is more like for parallelogram and triangles. Now in this case we have parallelogram on equal base. The previous one is parallelogram on the same base. Now this one here is parallelogram on equal base. So look at it here. Here they are not lying on the same base. You can see that the base of the white parallelogram is not the same as that of the yellow parallelogram. They are not lying on the same base. Now what does theorem say about that? He said parallelogram on equal bases and between the same parallel have equal areas. Their areas are still the same. But the fact that they have equal base and they are within the same parallel line, their areas are the same. And the next one says a triangle on the same base and between the same parallel as a parallelogram is half its area. Okay, now look at this triangle. There's a triangle here, triangle PAB. Okay, it's lying on the same base with parallelogram ABCD. They are lying on the same base. These are base here. The triangle is lying on the same base with the parallelogram. Now this theorem is saying that for the fact that this triangle lies on the same base with the parallelogram, okay, it means that the area of the triangle is half the area of the parallelogram. Okay, so whenever a triangle lies on the same base with the parallelogram, then the area of the triangle is half the area of the parallelogram. That's the theorem. And the third one here is triangle and still on triangle and parallelogram. In this case, it says if a triangle and a parallelogram are on equal bases and between the same parallels, the triangle is half the area of the parallelogram. Still the same thing. Though the first one, they are on the same base. Second one, the parallelogram and the triangle are not on the same base, but they have equal base. The base of the parallelogram here is the same with the base of the triangle. For the fact that they have the same base, all right, and they are within the same parallels, it means that the area of the triangle is half the area of the parallelogram. So that's what this theorem states. All right. Now let's now learn how to construct um, some areas. Okay, practical applications in construction of areas of some shapes. Firstly, triangle from rectangle. It's possible for us to create a triangle with the same area as a rectangle. Okay, when you are given a rectangle, you can create a triangle that will have the same area with that rectangle. And in the reverse order too, you can also create a rectangle that will have the same area with the given triangle. All right. So let us visualize this. Now we want to construct a triangle that will be equal in area to this given rectangle here. So how do we go about that? It's very simple. This is the given rectangle, right? So what you need to do is that you want to get exact rectangle that you are given. Okay, you want to get it and place it right above this rectangle. You want to construct an exact, that's the first step. You have to construct an exact rectangle of the same shape. And what do? You get your set square. You get your set square. My set square here. Okay. Any of them, whether it's a 30 by 60 or 45, 45 by 45, you will still get the same result. All right. Now, you position your set square in a way that to be in the angle 90 form. Place it at the edge of this rectangle. Let it be that. Let me adjust it a little for our view. Okay. Now I'm placing it in a way that it's going to be in line with the length of this. So I'm going to rotate it a little so that I can be in line to see. So then I will adjust it. I want to draw a vertical line of the same value, okay, with the breadth of the rectangle. So I get my pencil. Maybe I should use a white color pencil. Then I will draw my straight line. Okay. Okay. Now, the same way, I'm going to rotate I'm going to flip my set square to the other side, adjust it to the edge. Okay. And then get my white pencil again. So I'm trying to create another rectangle of the same dimension with the given rectangle. All right, that is achieved already. So I can take away my set square. I can now remove my set square. Now I need to know the length of this, the breadth of this. And how do I get that? I can still use my ruler or my set square, the graduated part. Let me see the measurement. So from what I have here, that is from 0. The breadth of this given rectangle is 0 to, what I have here is 0 to 3.9. So very simple. I will need to note 3.9 on the breadth of the new one. So 3.9. So within here, so I get my pencil and note that point. About around this area. So around this area approximately. So I've noted it. So the same way, I will move my set square to the other side of the line to also get the value of the opposite breadth. So I take it there, and then I mark 3.9 as well. It's noted. Then I can remove my set square haven't noted the measurement, I will now join these 2 points together to get the value I want. Okay, so I will get my ruler, but in my own case, my computer have a straight line, so I don't need to use ruler. I use my straight line, but you need to use ruler on your paper. So I join it together. So I've succeeded in creating the same rectangle as the given one. So the next thing is that I will take my ruler, place it at any point on this line here. I'll place it there and then draw a straight line that will go straight to this part, to this vertex of the given rectangle. Then I go to the same point again. I will draw another straight line to go to the opposite vertex of the given rectangle. All right, boom. I have succeeded in drawing or constructing a triangle. This triangle here. Okay, let me complete it here now. Let me complete the triangle. So this is it. Now this triangle that I've drawn is equal in area with the area of the given rectangle in the given rectangle in this cell, in this slide. This is the given rectangle, right? Now, if you have to calculate the area of the rectangle, you find out that it gives you the same value with the area of the triangle we just drew. So that's how to construct a triangle equal in area to a given rectangle. All right. So having said that, let's talk about also constructing a triangle. In this case, we are looking at a regular constructing a triangle that is equal to a polygon, the area of a polygon or a circle. How to construct a triangle whose area will be equal to the given polygon area or the given circle area. Very simple. To do that, all you need to do if you are given a polygon and you want to draw a rectangle or construct a rectangle that you want to construct a triangle rather that is equal in area to the given polygon. All right, all you need to do is, first of all, you draw the lines, you draw all the diagonals in the polygon to meet at the center, and then the next step is to, at the center, extend a line downward like this, and then you join up together. Okay, and then for that of triangle, that of a circle, we want to draw a triangle which area will be equal to the given circle. You need to also follow some steps that will make that possible. You will need to divide the radius of that circle into 7 and then follow the steps that is given. Maybe we should have a visual of this. Okay, this is a given polygon, and we are expected to draw a triangle that will be equal in area to this given polygon. All right. Now we need to know the type of polygon we have. In this case, now this is hexagon polygon. Why? Because it has 6 sides. 1, 2, 3, 4, 5, 6. So any polygon that has 6 sides is known as hexagon. Okay, irregular hexagon, because it is called regular hexagon because all the sides are equal. So any polygon that is having an adjective of regular has its side to be equal. This is a regular hexagon. Now we want to construct a triangle that will be equal in area to this hexagon here. So first thing is to join the diagonals. Okay, or draw all the diagonals given. So that we join. Okay, so we get a straight line. For you get the ruler, but I'm going to use a straight line here. So I join this point with this point. Then the other vertex with the opposite vertex here, and then the other vertex with the opposite vertex. So that's the first step you take. Now you can see that the 3 diagonals meet at the point. Now you need that point to construct a triangle, but before that, you need to know the length of each of these, the length of each side of this hexagon. So by getting your ruler or your set square that is calibrated, anyone works. Let me make it of the set square. So by the time I place my set squared there, I want to know the length. I want to know the length. From what I have here, for visibility purpose, let us place it outside. Or better still, let's use the side view that will be visible to our sight. Okay, let's use this other side of the length. Now, rotate it this way, and then I bring it close from 0. It's not in line yet, so you adjust it to be in line. Okay, now I've gotten in, okay, the alignment now. So from that means, for what I have here now, the length of this side of polygon is 2.6, okay, 2.6 centimeters. Now that you know that this is 2.6 centimeters, you multiply that 2.6, you multiply 2.6 by the number of side. You know, we have 6 side here now. So multiply 2.6 by the number of side. And how do you, so when we do that, 2.6, we have 6 side, according to hexagon, so 2.6 centimeter times 6 times 6. Okay. So, and what would that give us? So let's do the little calculation here. 6 times 6 is 36. So that's right, our 6. Then 6 times 2 is 12 plus 3, that's 15. So that's 15. And then we put our decimal point, and that's 15.6. So 2.6 times 6, 2.6 centimeters the length times number of side, which is 6 in this case, that's 15.6. So we have 15.6 centimeters at the total length. All right, 15.6. That 15.6 is very important that we know. So having noted 15.6, then we need to subtract 15. We need to subtract 2.6 from 15.6. 2.6 is the length, right? The length of each side. So 15.6, which is the total we have gotten, minus 2.6. So that will be giving us what? From what you could see here. So that means we have 6 minus 6 is 0. Then your point, 5 minus 2, that's 3. And then your 1 is brought down. So we have 13. So we have 13, right? Now the reason I did this is because we want this 15.6 to be the total line at the base here. Okay. Now I'm going to explain what I mean by that. Okay. Let's erase this first. So we have 13 left. If we subtract 2.6 from 15.6. Now that 13, if we divide it by 2 again, that will be giving us 6.5. Okay, so what we want to do now is that we're going to get our ruler. Please take note of those steps I just took to get these values. Now, get our ruler, put it on the horizontal form. Let it be in line with the base here. Now, I said dividing 13 by 2, that's 6.5. So, on my, okay, sorry, let me take my ruler to the last side so that we can see the calibration well. So here now, I'm placing, I need to get 6.5. Okay, hold on, let's adjust, let's move our hexagon a little. We can take away this for now, out of space, and then now we need our 6.5 now should be taken, the measurement should be taken from the edge of the side below downward. Okay, so we are going to draw, we're going to get our pencil now and draw 6.5 from the edge here down. and then we adjust our ruler to the other edge again, to the other edge, and measure. Okay, excuse me, that is far away from. Okay, so we have we also measure 6.5 at the other side too. Hope you remember how 6.5 is being obtained. All right, so let me extend it to the other side. Okay, now I need to go back and note my 6.5 at the other side. Okay, 6.5, so that I don't make mistake. All right, they must be equal size. 6.5 on the left and 6.5 on the right. Okay, so we stop there. So our 6.5 is within this side. So let's mark that side to 6.5 here, 6.5 on the other side. Now you can now remove your ruler and then get your pencil. Join this 6.5. You know, from here to here is 6.5. From here to here is also 6.5. Now join this point with the center where the diagonal meets. Sorry. Let's use another color so we can see it better. Now we are going to be joining this center here, this point here with the center, and then that same point from the center we join it at the other edge, and we can rejoin this to show that the triangle we are talking about. So that's it. Boom. So this triangle we have constructed now has equal area with this polygon given to us, following the step we just took. All right, very simple. So this is how to construct a triangle whose area is equal to the given polygon area. Now, what about when you are given a circle? If you are given a circle and you have to construct a triangle that will be equal in area to that circle, very simple too. Let's take away all of this. We have achieved our aim here. Now we are given a circle, so let's get a circle drawn. Let's get our compass and draw a small circle with it. Now maybe we are given a circle now. Okay, so it goes like this. So this is a circle. I'm given a circle of this size. Okay. Now let's reduce our circle a little too big. Okay. Now you are given a circle of this size, and you are expected. This is a circle now with a center, and you're expected to draw a triangle whose area will be the same with this circle. So what do? It's very simple. The first step you need to take is to get your ruler or your set square and draw a vertical diameter of the circle. Okay, I want to draw a vertical diameter of the circle. So our aim is to draw a triangle that will be equal in area to this circle. So this is it. So you get your set square or your ruler to draw a vertical diagonal. So let me get my pencil now. Okay, and then you draw your vertical diagonal. Let's make it white color. A vertical diagonal. And then having done that, the next thing, you can now take away your set square. The work has been done already. And place it somewhere. So the next thing is to now draw a radius. Okay, draw a radius from the center of the circle. It can go beyond the center. You can go beyond the circumference of the circle like this. Now, having done that, you can now divide this radius into 7. From here to here also is also radius anyway. But we're going to divide this line into 7 parts, equal parts. Okay, very simple. You just get your ruler. Okay, get your ruler, rotate it to be in the same line with that line you've drawn. Okay, so if it is 0.5 you want to do, fine. Okay, you can do 0.5. So you rotate it that way. See, adjust. Then begin to mark with your pencil equal side. Let's do 0.5. Let's do 0.5. Let's adjust it in a way that it will be in 0.5 form. Okay, let's adjust it. Let's start from 6. So you do this, and then you get your pencil and begin to mark. The first mark is already there, so we are using 0.5 now, so this is 0.5. So this one mark here, and that mark here, making 2. Remember it's 7 divisions, so this is the second one. The third one, you mark it 4. This is 5, and this is 6, and this is 7. All right, so I haven't done that. The next thing now is to get your pencil and join this point that you have drawn. Join it with the edge here, where the diameter meets with the circumference of the circle. All right, so with it you have done now, continue to draw parallel lines that will be parallel to this first line you have drawn. And how do you do that? Just get your set square. The set square can help you to draw a parallel line. Get your set square, adjust it in a way that it will be in line with this. Okay, adjust it to be in line with the first line you have drawn. Okay, adjust it. You see, adjust it a little until it's in line. So I haven't done that. We can flip to the other side. Okay, so the reason I'm doing this, the reason I have to flip is because I will need to place my ruler beside it. So I haven't made this set square to be in line with the first line. Then I will get my ruler. I want to draw a parallel line. I'll get my ruler, adjust my ruler in a way that it will be beside the set square, be in line with the set square, right? Okay, I'll bring it close to it. So I haven't achieved that. Then I'll begin to adjust my set square now along with my ruler. Okay, so see, I'll make sure that my set square is in line with my ruler until I get to the next point. Okay, so I can move until I get to the next point. This is the next point here. So when I get to the next point, then I get my pencil and I join again. Okay, I join again. Then I will still adjust. I will keep adjusting. I'll keep adjusting my ruler. Adjust again. Okay. So I adjust it again. So this is a practical work. So take a little time. Then when I get to the next point again, I will draw my line. I will join this with this. So I keep doing that until I've drawn the 7 points, the 7 lines. Do this again. I'll move it again to the next one. You see, along the ruler. Make sure that you are following the ruler that you have placed. You are holding the ruler with your hand permanently to the position. I draw it again and I move it again to the next one. These are parallel lines I'm drawing now. Okay. Again, be sure that everything is perfectly done. Okay, okay. Then you get here. So this is more tedious doing on the computer because you have to keep adjusting your hand until you get it. Okay, but it's faster on the paper. All right, then that's the last one again, and then I will join. That's it. Now, I haven't done that. I have skate through. I have skate through this. Okay. Now, the next step now is to still get my set square. I'm going to flip my set square upward like this, and then let me take away my ruler. It's done. Job is done. So I've done 7 lines. Then I want to adjust my set square now to be at 90-degree width, the vertical diameter here, so that I can draw a straight line, a horizontal straight line with it. So I wanna draw. The next step is to now draw a horizontal straight line down from the edge here. I'll bring a tangent. Okay, so get my pencil and I will draw a tangent to intersect with this. So now, what is now the next thing to do? Let me make the line longer so that we can understand better. Okay, maybe I can move this upward for us to see. Then this is it. So now I'm going to now get my compass. This is my compass. I'll get my compass to determine the radius of the circle. So I want to determine, so I'll adjust it to the length of the radius. Okay, so I haven't done it. Then I will now place the center of my compass. I'll place it at the tip here, at the tip where the horizontal line meets, and then I will swing it and then make an arc here. Move it again to the point where the arc is made. Swing it again and make another arc. And then move it again the third time. Okay, the third time, and then swing it and make an arc. Then lastly, I'm going to come here. I want to know the measurement of this distance between each of the line. So I get my ruler to know the measurement, either with my ruler or with my compass. So I'll go there and I'll come to measure. Okay, so if I come here now, is approximately 0.5. So I will come here and also measure 0.5. I'll measure 0.5. Let me take away my compass now. It's done with the work. So I'll come here and measure 0.5 at the last stage. Okay, you can see that it's taking me more time. So I'll come here, place it at the last arc I made. And okay, I need to make a little rotation so that it be in line. Okay, so come here. Okay, and mark my 0.5, get my ruler, my pencil rather, mark my 0.5 here. So I haven't done that, boom, my job is 90% done. So all I need to do is now to join this point here. Let me get my white pencil. Join this point here with your ruler. All right, get a ruler, this point here, join it with the edge the center of the circle, and this form the triangle. This is the triangle now. So this the point. So this is the triangle. This is the triangle. So this triangle now I have drawn is the same area with the circle. So that's how to draw a triangle with equal area with the given circle. All right. Now, with using irregular quadrilaterals, if you want to do this, you are going to draw the quadrilateral, and then you are going to do some bisection. So I'm going to give you an assignment to do this. Try it out, follow the steps, okay, and then you are going to see that it is very simple to do. Okay, this is given regular quadrilaterals. I will give an assignment to reduce this quadrilateral to a smaller version. All right, because of our time, we're going to be doing the cutting here. Thank you for watching and have a wonderful day. Bye for now.